Here at UCLA, we have a group of researchers who study the center of the galaxy, where we think there is located a supermassive black hole. And the reason we know there's a supermassive black hole there is because we can see the stars orbiting around it.
You can't see a black hole. Is that the way you can determine if there's a black hole, by the star's movement?
It's true that you can't see a black hole. By definition, a black hole is simply black, and therefore there's nothing to see. And the reason for that is because light cannot escape from a black hole, even if there's light being emitted from within it. But what one can see is stuff that's falling into a black hole.
If there's a black hole at the center of the Milky Way galaxy, could it suck Earth in?
We're far from the central black hole. So we're 25,000 light years away. And so we're so far outside the domain of influence of the central black hole that it won't ever have any effect on us.
If all galaxies have a black hole at the center, do you have to have one for the other to exist?
Do you have to have a galaxy to create the black hole, or do you have to have a black hole for the galaxy to form around? And this is one of the current big questions. There does seem to be an intimate relationship between the size of the black hole and the size of the central bulge of stars in galaxies, the total mass of that bulge, and therefore they seem to know about each other. Whether this means that the black hole grew within the central cluster of stars, and its mass was determined by just how many stars there were, or whether the number of stars that were able to gather together in the central bulge of a galaxy is related to how massive the black hole is a question that hasn't yet been sorted out completely, and it's something a lot of people are now working on. It's one of the exciting questions of modern astrophysics.